This is the 6-4 example 1 try it for 6th grade math. We are looking at a graph of eye colors for 120 students in the 6th grade about how many 6th grade students have green eyes. Let me get my pen working here. So about 16% of the students have green eyes. If we wanted to use estimation for that, 16% is a little bit of a difficult number to work with, so I don't think I would use 16%. I would probably say that 16% rounds up to about, here's this little equal squiggle means about, to about 20%, and 20% means 20 parts out of 100, and 20 parts out of 100 reduces to 1/5. So basically it would take about 5 of these green slices to make up this entire pie. So about 1/5. Sometimes when you're doing multiplication, rather than think about it as multiplication, sometimes it helps to think about it like the word of. So to figure this out, we need to do 20% of 120 students. 20% is 1/5. 1/5 of 120 students means if you took 120 and divided it into 5 parts, that one of those parts would be 20% of the students. Again, of means times. So we're going to change the word of to times. We're going to put down 120. We're going to make it look like a fraction, because we know that multiplying fractions is the fastest thing to do in fractions. 1 times 120 is 120. 5 times 1 is 5. And 120 divided by 5, I think, is 24. So approximately 24 students have green eyes. How does understanding fraction equivalence help you estimate how many students in the 6th grade have green eyes? Well, if you wrote 20% as an equivalent fraction so that you could multiply it by 120 would be one way to do it. So that's example 1. For example 2, the difference between rounding and compatible numbers can be a little bit complicated because they seem like they're kind of the same thing. Rounding happens when you follow actual rounding rules. So if we were to find, let's see, if we were to round 44% to the nearest percent, it would be 40%. 40% is equivalent to 4, well, it's 40 parts out of 100. And 40 parts out of 100 reduces to 4 out of 10, and 4 out of 10 reduces to 2 out of 5, so 2/5. So if we did 2/5 times, or 2/5 of, we're trying to find 56, but they want us to round 56. So if we round 56 to the nearest 10, that would take 56 and round it up to 60. So 2/5 of 60. Is this right? This is right. Turn it into a fraction. 2 times 60 is 120. 5 times 1 is 5. And I think we just did this math because 120 divided by 5 is 24. So about 24 students attend a planned summer camp. Look at how this looks differently when we use compatible numbers instead. So you would keep the easiest number to turn, to turn 44 to really is 40%, which follows the rounding rules also, which is 4/10 or 2 out of 5. But the compatible number for 56, that would actually be 50. 50 is a number that's compatible to 56. So even though 56 were to round up to 60, the number 50 is easier to work with than the number 60. So we can't say it's a rounded number, but we can say it's compatible. So 2/5 times 50, 2 times 50 is 100, 5 times 1 is 5, and 100 divided by 5 is 20. So in this example, we would say about 20 students plan to attend summer camp. And notice that these two numbers are not the same. Sometimes they are, but right now they're not the same, but they're awfully close to each other. And that is using rounding versus using compatible numbers. Okay, I guess there's only 2 examples for 6.4. Nice! Let me know if you're having trouble with the homework and I can help you with that too. So I will post this now.